All right, let's go. Number 10, the Methuselah star. You are a young cosmologist at Caltech Observatory. It's 2000. You're analyzing data from a star 190 light years away. Your measurements suggest something impossible. This star, it's older than the universe itself. The star is designated HD 140283, nicknamed the Methuselah star. It sits 190 light years away in the constellation Libra. It's a subgiant, an old star composed almost entirely of hydrogen and helium with very little iron or oxygen. Those heavy elements are only forged in later generations of stars. When you analyze a star's composition and luminosity, you can calculate its age. In 2000, astronomers calculated HD 140283's age at 16 billion years. That's physically impossible. It implies the star was burning bright 2 billion years before the Big Bang occurred. Panic ensued in the scientific community. In 2013, the Hubble Space Telescope was used to refine the measurements, hoping to make the impossible go away. They recalculated the distance, the oxygen abundance, the stellar dynamics. The new age came in at 14.46 billion years. While closer, it's still older than the universe. The only way physicists can sleep at night is by applying a massive uncertainty margin of 800 million years, which barely, just barely, allows the star's age to overlap with the universe's age if you squint hard enough. Here's the problem that made physicists lose sleep. The Big Bang happened 13.8 billion years ago. That's a hard limit. Nothing can be older than creation itself. It's like saying a child was born before their mother. But HD 140283 doesn't care about our logic. Your measurements say 14.46 billion years old. The universe says 13.8 billion years old. The star is 660 million years older than the entire cosmos. It should not exist. But there it is, burning, aging, defying everything we know about time. Imagine a fossil older than the rock it's buried in. Imagine a child staring at photos from before she was born. Imagine finding a wound that healed before the knife ever cut. That's the Methuselah star. A cosmic ghost. An impossible ancestor. Something that existed before existence itself began. Is our measurement of the universe's age wrong? Is stellar evolution theory broken? Or is there something about time itself that we haven't begun to understand? If the oldest star is older than the universe, then what else have we gotten fundamentally wrong? Number 9. Hercules Corona, Borealis, Great Wall 2013. Astronomers are mapping gamma-ray bursts. They expect to find a random distribution of explosions across space. Instead, they discover something that shouldn't exist. A wall, a colossal wall, made entirely of galaxies. They found a colossal filament of galaxies, a superstructure held together by gravity, but not 1.2 billion light-years wide. It is 10 billion light-years wide. This is the Hercules Corona Borealis Great Wall. It is so large that it spans more than 10% of the entire observable universe. To put that in perspective, if you traveled at the speed of light, it would take you 10 billion years to cross it. Essentially, the entire lifespan of the universe. Its existence is a violation of the standard model of cosmology. According to our simulations of dark matter and gravity, there has not been enough time since the dawn of time for a structure of this magnitude to assemble. The cosmological principle says, on the largest scales, the universe is uniform, smooth, homogeneous. But the Great Wall shattered that principle into pieces. It is like finding a fully grown oak forest just minutes after planting seeds. Gravity simply hasn't had time to pull this much matter together. Physics says it cannot be. Yet there it is. Imagine a wall so vast that if you stood on Earth and looked through the most powerful telescope, you'd only see a tiny fraction of it. Imagine a structure so immense that it bends the very rules of what's possible in our universe. That's not description. That's terror. A cosmic monstrosity that shouldn't be. What mechanism allowed this to form? What force compressed billions of galaxies into a single wall? And more disturbing, if something this massive can exist where it shouldn't, What else is hiding in the cosmos? What other rules are we breaking without knowing it? Number 8. Fast radio bursts from dead galaxies. April 2024 Breakthrough Listen Project. A millisecond of radio energy floods from the cosmos. Energy brighter than the sun produces in several days, lasting only a fraction of a second. But here's the horror, it came from a dead galaxy. A place where stars stopped being born billions of years ago. Fast radio bursts were first discovered in 2007. They are extremely powerful radio signals that last only milliseconds but release enormous energy. FRB 202400209A was traced perfectly to an ancient, dead elliptical galaxy. Scientists theorized these come from magnetars, highly magnetized neutron stars born from young, massive stars collapsing. But magnetars only form in young, active star-forming regions. And finding one inside a dead galaxy completely breaks astrophysical rules. Magnetars are newborns. They form when young, massive stars collapse. They exist in regions where stars are still being born. But FRB 202400209A came from an ancient, dead galaxy. A fossil. A cosmic graveyard. How did something that should only exist in the nursery appear in the cemetery? This breaks every rule we have about stellar physics. Imagine hearing a newborn baby crying from inside a mausoleum. Imagine finding a live coal burning bright in the frozen core of an ancient glacier. Something is there that has no reason to be there. And we have no explanation. What is creating these signals? What physics are we missing? And more disturbing, is the universe trying to tell us something? Are these signals warnings? Number 7. The Hubble Tension. 2024. James Webb Space Telescope. Scientists expected to solve a decade-old mystery. Instead, they made it worse. They proved the universe is expanding at 2 different speeds, and nobody knows why. 2 measurements, both precise, both confirmed independently. From the CMB, oldest light in the universe is expanding at 67.4 kilometers per second per megaparsec. From nearby galaxies, our cosmic neighborhood, the universe is expanding at 73 kilometers per second per megaparsec. The difference? 8%. That may sound small. In everyday life, 8% is nothing. But in precision cosmology, it's a chasm. The error bars on both measurements have been shrinking for years as instruments have improved. They no longer overlap. The discrepancy now exceeds 5 sigma, definitive proof of new physics. Either one of the most carefully conducted measurements in the history of science is wrong, or there's something about the universe we fundamentally don't understand. The James Webb Space Telescope was supposed to settle this. In 2024, it independently confirmed the Hubble Space Telescope's measurements, ruling out instrument error. The tension survived. It's real, and it's getting harder to explain away. Imagine measuring a person's heartbeat with 2 different devices. One says 70 beats per minute, the other says 73. That 3-beat difference doesn't sound like much. But if it's consistent, repeated, confirmed, then one of them is measuring wrong, or the person has 2 different heartbeats. That's what's happening to the universe. If we don't understand how fast the universe is expanding, can we understand anything? If the measurements that built modern cosmology are wrong, what else is wrong? Is our model of gravity incomplete at the largest scales? Or is there new physics hiding in that gap? Number 6. Tabby's Star 2015. Kepler Space Telescope discovers something that shouldn't be possible, a star dimming erratically. Not by a little, by 22%. Imagine the sun suddenly dropping to 78% of its normal brightness. Imagine it happening again. And again. Without explanation. The star is KIC 8462852, nicknamed Tabby's Star, after Tabitha Boyajian, the astronomer who discovered the anomaly. It's located 1,470 light-years away in the constellation Cygnus. It's a sun-like star, relatively ordinary in every way, except for one detail. Something is blocking its light in a pattern that defies explanation. Standard astronomy says there are only a few ways to dim a star dramatically: dust clouds, passing planets, stellar winds. But the dimming pattern of Tabby's star doesn't match any of these. The dips are irregular, sometimes sudden, sometimes gradual. The star dims, then brightens fully, then dips again. It's like watching a light switch with a mind of its own. In 2019, astronomers published a shocking hypothesis. What if this isn't a natural phenomenon at all? What if an advanced alien civilization has built a megastructure around the star? A Dyson swarm, a collection of solar panels or habitats designed to harvest the star's energy. It's the most famous of all SETI, search for extraterrestrial intelligence candidates, precisely because the data fits so uncomfortably well. But the scientific establishment recoiled. How could we suggest an alien megastructure without evidence? Surely there's a natural explanation we haven't thought of yet. But decades have passed and no natural mechanism has been found that matches the data. Tabby's star remains one of the most mysterious objects in the cosmos. Imagine a city so massive it casts shadows across a star. Imagine an engineering project so ambitious that it captures starlight itself. That's not science fiction. That's one hypothesis for what we're observing 1,470 light years away. Is Tabby's star evidence of extraterrestrial engineering? Or is it a natural phenomenon we simply haven't understood yet? And if it is artificial, what does that mean for humanity? How advanced is a civilization that can dim entire stars? Number 5. The CMB cold spot. In 2005, NASA released a detailed map of the cosmic microwave background, the oldest light in the universe, released just 380,000 years after the Big Bang. Scientists expected to see uniformity with tiny fluctuations. What they found was a region of profound strangeness. The cold spot is a region of space about 1.8 billion light-years across, where the cosmic microwave background is significantly colder than surrounding areas. Not by much, about 70 millionths of a degree. But in precision cosmology, that's a scream. The cosmic microwave background is like the universe's baby photo. Every pixel represents ancient light that has traveled 13.8 billion years to reach us. The temperature variations tell us about density fluctuations in the early universe. But the cold spot doesn't fit the pattern. It's too large, too cold, too isolated. These scientists scrambled for explanations. A void? A particularly empty region of space? But analysis shows the cold spot extends too far to be explained by a simple void. Another hypothesis emerged. The cold spot might be evidence of the multiverse. Perhaps we're seeing the gravitational imprint of another universe next to ours, a collision scar from the birth of reality itself. Other researchers proposed even stranger ideas. Perhaps the cold spot is where a parallel universe pressed against ours, leaving a mark like a footprint in wet concrete. Or perhaps it's evidence of a cosmic texture we haven't discovered yet, some fundamental property of reality that we've simply never detected before. Imagine looking at a map and finding a region that doesn't fit any known pattern. I'd imagine scientists debating whether that region proves we live in a multiverse. That's the cold spot. A cosmic scar. A question mark written across the ancient sky. Is the cold spot just statistical noise? A natural fluctuation in an otherwise uniform background? Or is it proof that our universe isn't alone, that we're neighbors in a multiverse we can barely perceive? Number 4. Dark energy evolution. Dark energy. The name sounds innocuous, scientific, boring even. But dark energy is the name we gave to the most terrifying discovery in cosmology. The universe is accelerating. And 68% of the universe's mass energy is this mysterious force that's driving the expansion faster and faster. For decades, we assumed dark energy was constant, a cosmological constant just as Einstein predicted. But in 2024, something extraordinary happened. The Dark Energy Spectroscopic Instrument, DESI, completed its first year of observations, mapping 5.1 million galaxies across 11 billion years of cosmic history. The data showed something that made physicists catch their breath. Dark energy isn't constant, it's evolving. It was stronger in the past, it's weaker now. This violates the entire foundation of our models. If dark energy is changing, everything changes. The universe's fate is no longer locked in. The Big Freeze, The theory that the universe will eventually expand so fast that everything tears apart might be wrong, or it might be even worse than we thought. Scientists don't know what dark energy is. It's not radiation, not particles, not any form of matter we've ever detected. It's described as a property of space itself, an energy density that permeates the vacuum. But that's not an explanation. That's just renaming our ignorance. Imagine 68% of everything, more than two-thirds of all the mass energy in the universe, being a force you can't see, can't touch, can't detect directly, and don't understand. Imagine that force evolving in ways your equations didn't predict. That's dark energy. What is dark energy? Why does it evolve? Does its evolution mean the universe's ultimate fate is changing even as we watch? And if we don't understand what comprises 68% of the universe, what does that say about our understanding of reality? Number 3, the Great Attractor. Our galaxy, the Milky Way with its 100 billion stars, is not stationary. It's not floating lazily through space. It's being pulled, drawn toward a direction astronomers call the Great Attractor. And the discovery came in the 1970s when astronomers noticed something inexplicable. Galaxies across a vast region of space, a sphere encompassing billions of light years, are all moving toward a single point. Not randomly, systematically, as if something massive is pulling them. The Great Attractor is so massive that it's bending the paths of entire galactic superclusters. The Virgo supercluster, containing billions of galaxies, including our own, is being pulled toward it. We're moving toward it at roughly 600 kilometers per second. That's 1.3 million miles per hour. But here's where it gets terrifying. We can't see what's doing the pulling. Astronomers have pointed their telescopes at the region. They've mapped everything visible, and there's nothing there. No massive galaxy cluster, no supermassive black hole, no quasar, just emptiness. Recent surveys suggest the Great Attractor might be something called the Shapley supercluster, a collection of galaxy clusters so massive it contains more galaxies than the Virgo supercluster. But even that doesn't fully explain the gravitational effects we observe. There may be dark matter. There may be gravitational structures we haven't discovered yet. There may be something else entirely. Imagine billions of galaxies all being pulled in the same direction by a force of unknown origin. Imagine looking at the direction you're being pulled and seeing nothing. No explanation. Just darkness. Just motion toward an invisible attractor. What is the Great Attractor? Is it a supercluster? Is it dark matter? Is it something our instruments can't detect? And if something that massive can exist invisibly in space, influencing the motion of billions of galaxies, what other invisible forces are shaping the cosmos? Number 2, supermassive black holes. In 2023, the James Webb Space Telescope discovered something that broke theoretical astrophysics. The earliest galaxies in the universe, formed just 300 million years after the Big Bang, contain supermassive black holes. Black holes a billion times the mass of our Sun. This is impossible. Black holes that massive should take billions of years to form. They grow by consuming matter, merging with other black holes, gradually accumulating mass. But the universe was only 300 million years old. There simply hasn't been enough time. The first supermassive black hole shouldn't have existed until at least 500 million years after the Big Bang. Yet, JWST found multiple examples of even older ones. It's like discovering a 50-year-old human being born just 10 years ago. This discovery has shattered models of black hole formation that were built over decades. Astronomers call them little red dots, tiny points of light that turned out to be ancient galaxies hosting supermassive black holes. Each one is a cosmic crime scene where the laws of physics have been violated. One hypothesis: perhaps black holes formed from primordial structures from the Big Bang itself. Imagine the early universe so dense, so compressed, that certain regions collapse directly into black holes without going through star formation. It's speculative, unproven, but it's the best physicists have. Another hypothesis: perhaps supermassive black holes merge faster than we thought. Perhaps the early universe was so crowded with galaxies that black holes collided and combined, growing exponentially. But the math doesn't work. The density needed is unrealistic. Imagine an object so massive it exists 1 billion years before its own formation becomes possible. Imagine black holes appearing in the universe 200 million years too early. That's not a minor discrepancy. That's a fundamental failure of our models. How did supermassive black holes form so quickly? Are our models of black hole growth completely wrong? Or does the formation of supermassive black holes involve physics we haven't discovered yet? Number 1. The Fermi Paradox. 1950. Los Alamos National Laboratory. Physicist Enrico Fermi sat down to lunch with colleagues. The conversation turned to UFOs. Fermi allegedly looked up and asked a simple question that would haunt astronomy for 74 years. Where is everybody? The Fermi Paradox. We've discovered 5,743 exoplanets. Astronomers estimate there are 2 trillion galaxies in the observable universe. Each galaxy contains roughly 100 billion stars. If even a tiny fraction of those stars have planets, and an even tinier fraction of those planets develop life, the numbers become astronomical. There should be civilizations everywhere. The Drake equation attempts to calculate the number of intelligent civilizations in the galaxy. Most calculations suggest thousands, some suggest millions, and yet silence. No signals, no radio broadcasts, no cosmic engineering projects, no evidence of anyone out there, just silence. Infinite, crushing silence. Several hypotheses attempt to explain this. The Great Filter. Perhaps there's a barrier that prevents life from progressing beyond a certain point. Either we're past the filter and alone, or it's ahead of us, and we're doomed. The Rare Earth Hypothesis. Perhaps Earth is extraordinarily lucky. Perhaps intelligent life is rarer than we think. Or perhaps the Dark Forest Theory. The universe isn't a friendly place where civilizations say hello and exchange recipes. It's a dark forest where each civilization is a hunter. Broadcasting your location into space is suicide. Every civilization that reveals itself gets destroyed. So everyone stays silent. Everyone hides. The universe is full of civilizations, but they're all in hiding, all terrified to reveal their presence. If the dark forest is true, then the silence makes sense. We're not alone. We're surrounded, but everyone is hiding. Staying silent, waiting to see if anyone broadcasts their location so they can be destroyed. Or perhaps the Boltzmann brain hypothesis is true. Perhaps the universe is so old, so infinite, that the most likely conscious observers are not biological beings and civilizations. They're random configurations of atoms that briefly achieve consciousness through pure probability. We might be statistical anomalies. The universe might be full of brief flickers of consciousness and nothing more. The most disturbing possibility. Perhaps civilizations inevitably self-destruct. Perhaps intelligence leads to technology, and technology leads to weapons powerful enough to destroy civilizations. Perhaps the Great Filter is ahead of us. Perhaps every civilization that gets smart enough to communicate eventually destroys itself. We've sent signals into space for 70 years. We've listened for voices in the void. We've scanned the cosmic microwave background. We've pointed our most powerful telescopes at the stars. And we've heard nothing. Nothing. The silence is deafening.